Alright, well, thank you for coming to my research presentation and joining us this afternoon. As Dr. Kirk stated, my research project this semester was looking at the functionality of the Microsoft Kinect and how it might be able to be applied to the field of physical therapy. This is my abstract. If you want to read it, it is in the Symposium manuals as well. But it's kind of long, so we're just going to go for a project overview instead. The goal of my project was to discover the potential of the Kinect for physical therapy purposes. So we're really looking at the field of physical therapy and the Kinect itself and seeing how maybe the recording capabilities and the API of the Kinect might enable someone to create a project that would assist people in physical therapy recovery exercises. So for example, if you have like an injury in your shoulder and you need to exercise your shoulder, performing this exercise, we were researching the capabilities of the Kinect to give you feedback on like how you're performing, how correctly you're performing that exercise, and yeah, how correctly you're performing that exercise. The research project was really more of a proof of concept, so while I have developed an application that's pretty functional, it's not meant to be like a production line piece of software. It's more just proving the capabilities of the Kinect. A lot of people associate Microsoft Kinect with video games because when Microsoft initially released it, it was attached with the Xbox 360 and the Xbox One. But recently, Microsoft has been trying to encourage developers to start using it for the Windows platform. And there's a lot of different applications that they're trying to push. This is one example that's on the Kinect developers website where they're showing off the capabilities of the Kinect, possibly to be used in like a clothing store. So the example is the lady's looking into what appears to be a mirror, but is actually a video screen. And it's using the Kinect to try and map the different clothing that she's wanting to try out onto her body so she can kind of get an idea of what the clothes will look like on her before she actually purchases them. So this is one application that Microsoft's trying to show. The Kinect could potentially be used for this. Another example that they had on their website was like at a snowboarding store, having like different vacation options, so you can see like different places that you could plan like a future ski vacation. So Microsoft's really trying to encourage developers to use the Kinect for more than just games, and recognizing the potential it has to really revolutionize the way that humans can interact with a computer with a hands-free interface. There is a new, more updated Kinect coming out soon, as you can see in the bottom right-hand corner. It's more of a squarish one, and it only has one camera, but they're updating a lot. They're going to increase the resolution and add a lot of new features to this new Kinect. It will be coming out this summer, so unfortunately I wasn't able to use it for my project. If you can see, I've got my Kinect over here that the computer science department generously paid for. So it looks more like the Kinects that you would see attached with the Xbox 360, but one unique difference to the Windows version is it says Kinect here versus Xbox 360. If you have an Xbox 360 version of the Kinect, that would be a primary difference. That's also the difference on the Windows version of the newer Kinect, as it says Kinect up there. It's hard to see, but I was really looking at the physical therapy applications. So like I said, helping users or patients perform recovery exercises. The application is used to provide feedback. So if you're doing something wrong, like if you've got your shoulder out of place, it's going to let you know that you're performing the exercise incorrectly and you're not going to be recovering as well in the way that you're currently doing the exercise. It also provides positive feedback in order to let patients know that they're performing the exercise correctly. I built in little coins that you collect. So it's, like, it's kind of like a fun little game. It's similar, reminiscent to your Mario days. So it's a nice little interface, and you get positive feedback, and it's encouraging when you're doing the exercise correctly. One great thing about this application is it helps patients recover more independently because you don't need a physical therapist to be there with you if the program is giving you feedback. You don't have to have the physical therapist there to say, hey, your shoulder's off. Like, the program will tell you. And so it helps physical therapists accommodate for more patients, and it also helps patients to recover more around their own schedules. So they don't have to schedule appointments with a physical therapist and things like that. So just a brief overview of how the Kinect actually works is it actually takes in 4 sets of data, and these are the sets of data that it'll present to the programmer to make use of. So we have 4 different data streams: the color stream, depth stream, skeletal stream, and audio stream. The color stream is going to be your basic video, like if you're recording on a camera, that's what the color stream is. So it's kind of like, it's just going to record what it looks like what we would see as the video, is the color stream. The depth stream, this is going to be presented in a grayscale format. It's going to look like the color stream in the fact that it's actually showing video of what's occurring, but it's all in grayscale with things that are further away being darker and things that are closer being lighter. So for example, on the depth stream, if I had my hand over here, it's going to be rather dark, and then the closer I get, my hand would light up, and the wall would always be dark to reflect that it's further behind. The skeletal stream is not actually recorded, it's generated using a combination of the depth and color cameras. And what it does is it presents the programmer with the opportunity to use skeletal point information that's kind of calculated off the depth. The Kinect tries to recognize how your body is shaped, and it recognizes a human form. And it'll try and approximate where your wrist is, where your elbow is, where your shoulder is, and it'll get like a good idea of that. The audio stream is just basic audio input, so like the Kinect's microphone will give the programmer the opportunity to use speech recognition, which is also built into the Kinect. If you've ever used it for the Xbox or the Xbox One, you'll know that the Kinect is used for voice command. For my project, here's a picture of the actual application, NV20, the common housing place for computer science students. So this is the general interface. As you can see, there's a little user interface bar down at the bottom to present the user with some feedback. The way that the application works is right now it runs on 4 different states, although one of them is not used. I have a menu state, a ready state, an exercise state, and a recorder. So ideally, in the menu state, which I did not have time to implement, so the application just kind of goes straight into running. The menu state would be like a nice menu where you can pick how many repetitions of the exercise you want to do, which exercise you want to do, and things like that. Currently, there's only 1 exercise built in, and then with the recorder, you can change that exercise to a different exercise. The ready state is kind of the state you're in when you just first start the application, you're getting ready, you're not quite ready to do the exercise yet. And then once you're ready to do the exercise, you'll initialize the exercise state, which is where the program will start performing calculations, and then it'll start giving you feedback on how you're actually performing the currently loaded exercise. Also, one of the most recently added features that I really enjoy is the recorder, so you can actually record new exercises. And this gives a physical therapist the opportunity to record an exercise for a patient to use. I will demonstrate that in a live demo. So like I said, we have visual confirmation. So if you can see over in this picture over here, we've got little warning signs because these joints are currently out of place, and I'll explain that a little bit more later. And we've got the coins, and if I go back, you can see there's if you can see these coins that are turned and these coins that are faded, those are coins that were previously collected and are floating up. So it's a positive confirmation that you're doing the exercise correctly. So there are different kinds of, for the way the application works is there's different kinds of exercise joints. And exercise joints are the joints that you're going to be focusing on during your exercise. So if you can see up here, it's a little hard to see, but there's a red circle here, a red circle there, and you've got 2 warning signs. The 2 red circles represent stiff joints, and what that means is those are joints that you want to keep in place. So like if I'm performing an exercise where I'm raising my arm, which is the one that I'll be demonstrating in the video, or in the live demo, I want to make sure that I'm not slunched over because that'll be exercising different muscles than the actual muscles that I want to be trying to recover. So if I'm slouching over, that's incorrect. So these stiff joints, it's going to lock. It's going to tell me to keep this joint steady and this joint steady, and that's to make sure I'm not going off balance and using the incorrect muscles. The next joint is the reference joint. You can see there's a green circle right here. If I'm exercising my arm, the joint that I'm moving about is going to be my right shoulder joint. So that's going to be our reference joint. And then our moving joints, if you can see, the 2 without circles, but they've got dots on them, are my elbow and my wrist joint. These are the joints that it's going to be tracking to make sure that I'm actually moving my arm up and down. And so it's going to be looking to see that I'm moving them about this about my shoulder, and I'm exercising my arm as such. There is potential for new exercises. The way I built the program, I tried to build it so it was very modular and future exercises could be loaded in easily. And that's a potential use of the program. So issues in development. When I first started developing for the Kinect, I found that there were two different avenues that you could go through. There's XNA, which is Microsoft's own kind of, it's gauged towards independent game development, but it's a framework for developing different applications. And then there's the .NET WPF route, which is more of, it's used for generating like nice Windows applications that look pretty, and having to choose between those two, they both seem like very viable options for making the application. But I had more experience with the XNA framework because I used it in a class the semester prior to this, thanks to Dr. Kirk, which I really enjoyed. And so because of prior experience with XNA, I chose to use that. There's a little bit of an issue with the coin locations. The coin locations are generated on the fly to try and accommodate different size patients. So when you're going into the exercise state, it will perform a calculation to see how far your arm is from, your different joints are from the reference joint. And so if you choose to mess that up, it will cause a problem because the Kinect's not going to know the difference. If when it's performing those calculations, you go like this, then it's going to generate the coins in an incorrect fashion because you've messed up the calculations. So that is one issue that could potentially be optimized in the future. Also, I try to warn users against performing the exercise too quickly, but the calculations for that are still finicky, and I'm working on sorting those out, but I will be able to demonstrate that. Another issue is small text. One thing I noticed is that the ideal distance for using the Kinect is 2 meters away, which makes it hard to read text on the bottom of your screen on your computer screen from 2 meters away. Like normally computer screens aren't meant for that kind of interaction. So thankfully for you guys, the text will be rather large on this projector screen, but ideally when you're performing the exercises at home, it will be a little bit more of a challenge. There were continual bugs that popped up and things happen, and that's just how programming goes. They're like babushka dolls. You take care of the big problem, and then you got a smaller problem that comes out of that, and then a smaller problem that comes out of that. So you just gotta work on it and get through it like that. So improvements for the future, I do hope to implement a menu one day, and ideally I would like to use voice commands too to like start the exercise and end the exercise. Also, I found out that the Kinect actually has a built-in motor for camera tilt, and so that would be an ideal thing to build in so that it accommodates the patient's height. So when the patient's performing the exercise, it would be ideal if it focused in on the area that actually needs to be exercised. Also, I wanted to develop a way to make the user be centered within the camera. So ideally, you want your patient to be in the center of the camera area so that they have the optimal amount of area to perform the exercise. But I don't have requirements for that built in, so the user can start the exercise from anywhere in the camera range, which would be problematic if, for example, you try to start a right-hand exercise and you're on the very edge of the screen, then your coins are going to be generated off the screen. So that would be an issue. And now I would like to give my live demo of my application, which you guys have all been waiting for. So, all right. Oh. Takes a little while to boot up since it's in full screen. So, all right. So there. Let's move this chair real quick. All right. So you guys can see me, and you can see how the program is actually picking up the skeleton. So as you can see, we have the color stream here, which is the actual picture of me, and then we have the skeletal stream that's overlaid on top of it. And then you have 3 green circles, which are going to show the different joints that we're going about. These 2 are going to be stiff joints, and then this one is going to be our reference joint. So I will do a quick demonstration of the actual exercise. If I put my hand on my left-hand shoulder, it will start the exercise state. And now it tells me on the bottom to stand still so that it can perform the calculations to generate the coins. So as you can see, there's 2 red circles in the top left to indicate that those are stiff joints, and it wants me to keep those still. So if I move out, it's going to give me a warning against that. And if you look down the bottom, there's continually text generated to give you feedback on what's currently going on. So right now it's giving me a warning, joint out of place. So, and then also if you look in the bottom right hand corner, I have 3 little icons that will generate different errors. So if you can see, there's a red icon that's lit up with what looks like a running man, and that's to let me know that a joint is out of place. Also, if you look at the warning signs, if I move down, those warning signs will move with you to let you know which direction you need to move back in order to get those stiff joints in the correct place. And I mean, that is ideal so that people can't perform the exercise incorrectly, like if they're slouched over, they're doing something incorrect. So now if I actually go to collect the coins, you'll notice they pop up and to give us feedback that performing the exercise correctly. And if you'll also notice in the bottom right hand corner, there's a repetition counter that lets me know how many times I've successfully completed the exercise. And if I go on a downstroke, you'll see that it increments to accommodate the fact that I've finished 1 full repetition. Another thing to note is that the coins are built to be collected 2 at a time, so that you have to collect the coin for each moving joint at the same time. So if I try and collect this coin by itself, it won't let me do that. And also if I try and collect these 2 coins before I collect the other coins, it's not going to let me do that, because the exercise really wants me to perform it in the correct order. Another thing to note is, and so I'm going to finish this exercise. The program is currently set to finish on 10 repetitions of the exercise. Oh, that's what I was going to say, sorry. To demonstrate the moving too fast, if I move my arm up and down too quickly, you can see the warning signs popping up there. There we go. So let me know that I'm going too fast. And there will also be an icon. The orange icon on the bottom right will light up if I move too fast, and it'll display a textual output to let me know that I'm moving too fast. So once I finish the exercise, it says, "Finished exercise, congratulations," and it'll put me back in the ready state so that I can start a new exercise. As we all know, people get injuries in many different places, so not everyone's going to get their right arm injured. So you want to be able to perform the exercise on the left shoulder as well. So in order to do that, I have another gesture built in to switch the direction of the exercise. So if you notice in the bottom, I kind of took my hand away quickly, but it says exercise direction change. So now if I go into the exercise mode again, it's going to perform these calculations, but what it's going to do is that my exercise is now actually going to be on the left-hand side, so that you can build exercises once and then have them set in so that people who have the injury on either side of their body can perform that exercise. And now I'm going to finish this up real quick. Sorry, got to do all 10. Alright, so now the final thing to demonstrate is I'm going to demonstrate the exercise recorder. Come on, work with me. There you go. Alright, so now if you notice in the bottom, it says, "Please indicate the leftwise reference joint with your hand." So I'm going to build the same exercise that I was just performing, but I'm actually going to build it on the left side, and I'll do a couple tweaks to make sure that you can understand that it is a new and independent exercise. So I want my reference joint to be my left shoulder, because that's going to be the joint that I'm doing the exercise about. So I'm going to put my hand over, and if you notice in the bottom it says joint recorded, and my little hand icon has disappeared to let me know that that has been recorded. Now it says, "Please indicate the moving joints with my right hand." So I want my elbow to be a moving joint, so that joint's recorded. And then I want my left wrist to be a moving joint. Alright, so that's recorded. And now to indicate that I have recorded all of the moving joints that I want to, I'm going to put my hand over the reference joint again. And now it's going to say, "Please indicate the leftwise stiff joints." So if I'm performing the exercise on the left side, I want my stiff joints to be my center, Microsoft calls it the center shoulder. I'm not sure what most people call it, but I have my right shoulder. So I'm going to indicate my right shoulder as a stiff joint, and then I'm going to indicate my, oh, there it was, center shoulder is a stiff joint. Oh, come on, record it. A little finicky, joint recorded. All right, so now it's got both of those recorded, and now if I go over, it's going to put me in the goal location recorder. So now what I want to do is I want to stand still, and it's going to record 3 different goal locations. So this is going to be goal location 1, and then our other exercise recorded at a 45-degree angle, so for goal 2, we're going to record it there, just to let you know that there is a difference in the exercise we're recording. And then for goal 3, we want to record there. So now our exercise is recorded and is currently loaded into the program. So if I go into the exercise state again, it's going to have me perform the exercise that I just recorded. And as you're going to notice, those coins are closer together because I recorded them closer together. When I did the previous demonstration of the preloaded exercise, it was at a 45-degree angle and then a 90-degree angle. So as you can see, this is in fact the exercise that we have recorded and isn't the exercise that I preloaded. So it does function properly. The problem is that those coins are so close together that I actually ended up collecting both of them on the upswing as well. So that's something that you'd want to note. Yeah, so that is a full demonstration of what the program is capable of now. Ideally, there would be a database with preloaded exercises where we could save a larger number of exercises to accommodate the different needs that patients would have. But as is, I have that one preloaded exercise and then the exercise recorders that you can record new exercises. And the Kinect doesn't really like when you leave and it has a hard time drawing the skeleton. But I think that is all, and now I am open to questions. So, yes.
Is there any other exercises that like involves like collecting other things besides coins?
No, the coins are the only mode of feedback right now, but that could be another thing for future implementation. One of the initial goals of the project was to have like fun interactive experiences for the patient. So ideally there might be some kind of game that I'm able to implement into it later as well, so you have different options to choose from. But since this will be accommodating for patients of varying ages and varying modes of like interest, you don't want to have, for instance, like a game with rainbows and stuff for like an elderly patient, but you might want to have it for like a younger patient. So ideally there would be different ways that you could get that feedback to accommodate like the age and the interest of the user, but that is not currently built in yet, no. Yes?
So, I mean, I had an Xbox Kinect for like the 360, and sometimes when you're playing the games, it's really like, you'll like zoom off when you're trying to do something like slow or something.
Yeah.
Like, is that, have you thought that all through the speed calculations and stuff like that, or is there still, because I just know from the games, like, it can be very finicky.
Yeah, the primary problem I was having with the speed calculations was actually the way that C# performs tangent functions and the feedback it gives you. I don't know how many of you know the unit circle, but generally the way the unit circle works is it goes from 0 to 2 pi, but the way that XNA or C# chooses to interact with it is it goes from 0 to pi and then 0 to negative pi, which is kind of unique and different. And I think that's where I was having trouble because the speed calculations are actually performed using trigonometry to find out how fast you're moving over the course of a couple seconds. So I think that's where the issue was coming in. The primary issue with the speed calculations is sometimes it would pick you up moving at really slow speeds, and then sometimes it would pick it up moving at the regular speed. And we don't want to tell the user that they're moving too fast if they're not, so I raised the threshold high. So hopefully it would only show up if they're actually moving too fast. Yes?
Your program initiation is like right hand on left shoulder.
Yes.
What if their exercise like prohibits them from making that motion?
That would be a difficulty. That's why one of the future implementations that I was talking about is speech recognition, because that would be something that all users hopefully will be able to do. There is a limitation to the Kinect in that if you were disabled in multiple fashions, like you were mute and crippled, and like it will have difficulty. I don't have a way to accommodate for that. But the goal is to accommodate as many patients as possible, and that would be one of the things that I've implemented in future implementations is the speech recognition. But it was one of those things that I just didn't quite have time to get around to do. So, yeah. Dr.
Have you really talked to the physical therapist about the practical use about this? What's the feedback you got from them?
Well, initially we talked to Mr. Chris Pauly about, or Professor Chris Pauly about this actual project, and he seemed very interested. But I've been finalizing a lot of features in this past week, and so he hasn't seen it in what is now a more finished state. But hopefully I will get to interact with him again later and let him know the full capabilities I have with it and different things that are still potentially able to be added. And I think that there might be a lot of interest in possibly using this in the realm of physical therapy. The only issue is that this is really more of a proof of concept thing, and so it wasn't actually, I mean, I tried my best to make an actual full-fledged application that could give feedback, but it wasn't even necessarily meant to do that. It is a proof of concept, and I feel like I have effectively proved that the Kinect can be used for physical therapy recovery. So yeah.
I've always wondered, and I think I know the answer now, how bitcoins were being generated.
That's how. They have people in a back room somewhere.
That would be motivational.
Yes, actually.
Well, in terms of the project size, how many lines of code you have?
I wish I had looked at that because it's quite a lot, and I can show you briefly. I'm not sure how much this will interest people, but I had to make use of a cool feature that Dr. Kirk, yes, there is an error, and I don't know where that comes from, so don't ask about that. It happens every time. Okay, so if we want to briefly look at the Kinect code, I made use of a nice feature that Dr. Kirk taught me back in the day, which is called regions, which helps condense the code. So you are looking at the whole program right there, but if I press the plus icon, it's going to expand a bunch of stuff. And this is all unused code because this is the speech recognition, so I'm not actually using that. So in here is going to be all the code for recognizing and setting up the Kinect, because that's actually a process that you have to go through. And I took that code from stuff that Microsoft provided. This is all the code for image processing and the skeleton generation. And if we open these up, there's more code written in there and more and more. These three are mostly code that I got from Microsoft that is surrounding the actual Kinect API, and so those are things that were kind of given to me. The rest of these are stuff that I built, so checking input. There's actual keyboard input that you can use, and then there's like, these are for recording the three different gestures. So if we look right here, this is to record the, you can see the game state gesture. So this is to go from the ready state to the exercise state, and that's all the code to just go into the exercise state. So I mean, that's a brief like idea of how much code I have. If you want to see something that's, yeah. And then like you've got the update. This is where everything is continually updated each frame. And then we have the, let's go down here. Where is it? Go back. The drawing. This is where everything's actually drawn on the screen. So if you can see, like, I have the three different game states set up here. So menu, I'm not drawing anything. They don't actually have a menu. It's just idealistic. Here's everything that would be drawn in the ready state versus everything that would be drawn in the exercise state. And you can see how there's different things that we actually want to draw. Like, we want to display the coins in the exercise state, but we don't want to display those in the ready state. So I mean, this kind of gives you a brief idea of how much code I have, because I can expand all these things and try and impress you with how much there actually is here. But it's not actually worth the investment of looking through it all, because a lot of people won't understand it.
You know, I'm afraid we're about out of time.
Okay.
Is it a quick question?
Yeah, just real quick, what was the hardest thing you sought to code? Like, was it the recording stage? Was it the skeletal recognition? Like, what was...
The hardest part I actually had is I actually spent like a couple hours just trying to figure out whether I would use XNA or WPF. So even though I mentioned that in one line, like it took me like a couple hours to figure out which like framework I wanted to use. So that was one of the most challenging things. The recorder, God bless me with like good productivity, and it took like a couple hours, so like 4 hours to actually set up the recorder. But that was actually after I already had a lot of other code in place for like recording gestures and stuff. So everything's kind of built and staggered on top of each other, and it's hard to say what the hardest part actually was. So, yeah, all right. Thank you very much.